welcome back from the break. Now we change to another topic, open source compliance from the University Erlangen. That's the location where we have the most employees from Siemens, the biggest Siemens site, kind of the Siemens city. Welcome, Dirk.
Thank you very much, Roger, for the introduction and inviting me and for my talk here. So it's a little bit of a change. My topic is obviously open source compliance, and I take the perspective of a software vendor, or a vendor meaning a company which sells products. So not so much an open source maintainer's perspective, though based on the compliance content, we'll definitely get there. So what does compliance mean? Well, you have to comply with some requirements that some third party puts on you. That's the idea of compliance. And with respect to open source, that's typically license compliance and also now regulatory compliance. And if you don't comply with the requirements, all kinds of negative consequences could follow. The original or old license compliance, you may not even have the right to distribute your software any longer, but also now penalties thanks to maybe missing regulatory compliance. So that's what I'll be talking about today. I'm curious about this cloud. My topic is open source in products. So the product itself, the code of the vendor may or may not be open source, but definitely they use a lot of open source components, the dependencies. So I'm kind of curious, who of you thinks that, imagine your average web application. Who thinks there's definitely open source code in a regular web application today? All hands should go up, really. All right, so who thinks there is more than 20% of the code doing its job in there is open source code? 40%, 60%, 80%. That's not a lot to think that any longer, 99%. All right, so obviously it depends a little bit on the application. If you're more embedded firmware, then it's less, but people tell me 50% open source code. The average startup, which just puts a thin veneer of their own code that creates the business value on top of a large stack of open source commodity, if you will, that's easily beyond 95%. So open source is just really substantial. We'll see a little bit more numbers in a second. So I probably don't have to tell that here, but I do talk to hardware vendors a lot, and I ask them, well, now that you realize so much open source code in your product, who's actually responsible if something's wrong with that open source code? Now, software folks here probably will say, well, it's a product we are selling. We are fully responsible. A more traditional mindset that is still very prevalent says, wait a second, these open source projects, we don't develop them. We are not responsible. They are our suppliers. They are responsible. Exactly. Someone's laughing, and that will be a laughing point later on. Of course, open source projects are not suppliers, but that won't stop a lot of vendors from thinking that way. So my point here is all that third-party code, predominantly open source code, in your product that you distribute to your customers from the vendor's perspective is also your responsibility. And that creates a lot of challenges. I'll approach this by looking at a fundamental data structure, the SBOM, which who knows what an SBOM is? All hands up? Almost all hands up. Fabulous. But I still want to talk a little bit about the challenges with SBOMs and then how you use it to address these compliance challenges. So I'll use some software we're developing. You can use it for free, where you basically look at some project and analyze it for the SBOM dependency graph and all the resulting things. We use Vercel Surf as a simple open source library here, as if it was an application. So we start with the SBOM. The SBOM, the software bill of materials, is that more or less linear list of all your dependencies, all the components that you put into your product in addition to your own code. You need to collect a lot of information depending on how elaborate you want to be. You may think that it's not so big a problem. After all, you can't build your product if you don't know your components. But what that gives you is the libraries, the components. So the Perls, perhaps the package URLs that identify the library, how you download it from a package manager maybe, or hopefully you have your own internal artifact system, packaging system, and then you have your SBOM. Well, so yes, that component identification is basic, but you also may want to know the license for license compliance. That already is tricky. Before I get there, I want to point out that to motivate this, that what used to be just a data structure to help you in engineering, just understanding what's in your products and putting it into the form of an SBOM, that this was a helpful data structure, still is a critically important data structure, but it's also a purchasing requirement now. So if you're a vendor, you need to have that SBOM. It started, I'm not sure it started there, but that's the Biden administration in the US still, who made it a purchasing requirement for US governmental agencies who would not buy software from you if it didn't have a clear SBOM. The motivation is security. They want to know what's in there. They want to track what's in there. They want to be able, long after they purchased from you, want to be able to look at potential new CVEs in the components of your product. So it's actually not surprising if you're Volkswagen or some large company, you looked into your software supply chain, you always wanted to know exactly what's going to come to you. Not so much for security, originally more for license compliance reason. Is there some supplier who gives us copyleft code that we don't want in our product? So then you want to know as early as possible and not in the very last second when you try to put that supplier's component into your product and realize you can't or you won't because it's copyleft licensed. So here are the challenges that result from not knowing or not getting right what's in your product. Your intellectual property isn't safe. That's the copyleft license. If your business model is based on proprietary licenses, then you can't have copyleft license code in your products. I'm simplifying a bit, but that's how it is basically. More importantly, you need to create those pesky legal notices, third-party notices, paying credit to where credit is due, which is the open source programmers. You need to tell your customers, this and that component, open source component is in my product, copyright so-and-so, the original open source developers. If you're an open source developer, it's with all licenses, almost all licenses, you're right to get the credit for your contribution that somehow is commercialized by some company. So it's your right, yeah? And some people take it very seriously, properly so. If you don't know what's in there, you don't know about vulnerabilities, and increasingly we have regulation like the Cyber Resilience Act that requires an SBOM, that requires secure by design, security processes, that requires monitoring and watching over what's long out there in the marketplace, what you've long delivered and need to keep secure. So in order to get to that SBOM, you need to do something called software composition analysis. Is that easy? Well, the first approximation is easy. Again, it's the build tool where you declare your dependencies. Hopefully you have the scopes right. So these are production dependencies, these are test dependencies, and then you know precisely which libraries to include in a binary that you deliver. You can kind of guess it. So for one line of code that, let's assume your proprietary business model, for one line of code you write, how many lines of code are there in the first level dependencies? So first level dependencies, the libraries for which you declare your dependency. We are using Apache comments. So that's the dependency. And you write that down. For one line of code you write, how many lines of code first level dependencies are there? What's the relationship? Is it?
That depends on the ecosystem.
That's good. I think less strongly so, but let me give some impression. We are not talking precise number. Who thinks it's 1 to 5 or more than 1 to 5? 1 to 10? All right, more than 1 to 10? Right, so it depends. The examples we looked at are usually 1 to 10 from your code to first level dependencies. And then beyond the first level dependencies, the second level, third level, a whole boatload, iceberg under the waterline, if you will, of indirect dependencies beyond the first level. The libraries that the libraries include, that you include. So the second, third, and so forth. And that goes from 1 to 10 to 200 maybe. So it's a substantial explosion, depending on how much open source code in total, of course, is in your product here. And you can see it illustrated here. That's a toy academic project, 160 dependencies in total. This is the code we wrote, our first level dependencies, and the whole iceberg visualized underneath it. So there's just a large amount of libraries, of course. You have standards to capture, represent in your tools, the SBOMs. You can work with it, you can deliver it to your customers, etc. So if all you need is to know is the library that you include in your products, you have a Perl, you have your declaration of dependencies, they pull the others, that's okay. That's automated, because otherwise you can't build and deliver a product. However, if you want a real SBOM, or if your customer requires detailed, precise SBOMs, you have to do much more. If you're unfortunate in a sense, or maybe that's just how it is, you may be asked to identify all the code snippets in all the open source code that were copied into that open source project from somewhere else, bringing with it its own license, its own potential vulnerabilities that don't originate from that open source project that they're from. Lots of open source projects, we can safely assume, come under a license, declared. Lots of copy and paste subverted that license. As long as nobody asks, maybe not a problem, but some customers are very picky. So we have this whole ecosystem, business of license clearing, license scanning, which goes beyond identifying just the libraries, all the way at looking at snippets in your dependencies, not just your own code. No, in that times 100 or 200 additional code that you didn't write, which you need to identify mostly to figure out that there's no copyleft license code, like copied from Stack Overflow. That's a copyleft license. Wonder how many people copied from Stack Overflow into an open source library and subverted an MIT license to the very weird Creative Commons share-alike of Stack Overflow. All right, let's not go there. But even the license itself is sometimes tricky. You ask the package manager, well, maybe the metadata on the package manager is correct. The library can be identified, yeah, but the license was declared when the library was first set up. Maybe it has changed and the metadata never got updated. Maybe the link to the source code is the right one, maybe it's not. Often it's out of date. So already the metadata on the package manager is tricky and may require review by hand, basically. So tools help you analyze the dependency graph, create an SBOM, and possibly get you going on by hand review of what's in your product. Here's an example. One thing, of course, you want to know is vulnerabilities, etc. The slides, I believe, will be made available. So then you need to, if you really need to create a correct SBOM with all the details, you do have to step through all the source code, maybe or increasingly with the help of an AI, but still the human has to sign off on it. So you have tools like Fossology and open source, or our project here, where you just step through the source code, look at copyright statements, sign off on them, and say, yes, that needs to be included. So again, why? Because the SBOM is the fundamental data structure on which you have to build compliance. Compliance, again, is license compliance and regulatory compliance. I'll be fast on the license compliance part, though surprisingly, many open source folks care about the licenses, so do I. So the big one is first, in my opinion, overhyped big one is copyleft. Copyleft means that if you don't comply, so open source license, okay, give you all these rights, great. You have to comply with these requirements or you cannot distribute the open source code. So it's your right that anyone who uses your open source code complies with the requirements of the license. You may think it's MIT, all it says is this permission notice shall be included in all copies. So that seems easy. If you don't comply with that, you don't have the right to use the so licensed code. The specific problem is the copyleft license. Even seasoned open source folks sometimes forget an important distinction where it applies. First, you have two use cases of open source. One is the end user. So that's the party who, if you're an open source programmer, gets the code and then uses it. Usually no obligations follow. It's only if you are, our perspective here, a vendor who takes the open source component as an intermediate party and distributes it to a third party, meaning you sell it. So only if there's a third party, your customer, then the copyleft effect or the license obligations in general kick in. So I won't dwell much on copyleft. Feel free to ask me about it. It's my bread and butter work. The copyleft license is a series of licenses, mostly the GPL 2.0 license, of course, that we know from the Linux kernel, is a license that propagates. So if you include copyleft license code, I'm simplifying, in your own code and pass it on, then you have to use the GPL license, an open source license, and cannot apply your proprietary license. Something that vendors usually don't want, which is why they try to avoid to have copyleft license code in their products. How real is that problem? So here's something you may not know. The Software Freedom Conservancy is a nonprofit organization created to make it easier to enforce, in particular, copyleft licenses. It used to be engaged individuals who fought and stood up for the rights of open source programmers. It's pretty hard if you're just a private party suing VMware or something. So we have a nonprofit, or there is a nonprofit, the Software Freedom Conservancy, which takes that over, takes donations, has powerful lawyers, can stand up and defend open source rights in court. And they're doing it, of course, not somehow, but always in Musterklagen, in situation where they try to set an example for others then to follow. So they are always exploring the boundaries of where the open source licenses are going. And there's a super interesting lawsuit right now, the Visio lawsuit, and I'm still taking a vendor's perspective here, where the Software Freedom Conservancy is suing Visio, a TV manufacturer basically, over license and compliance. They have a Linux kernel in the TV sets, and they are not providing the source code. Well, with the copyleft license, they must provide the source code to their TV sets. And the new thing here is that the Software Freedom Conservancy is suing as a plain customer of Visio and not as an open source programmer. So in the past, law enforcement, legal enforcement of licenses was always, here's the open source programmer who's being wronged because these are their conditions and they were not fulfilled. Now it's just a customer. So we go from one open source programmer to 1 million customers, where the Software Freedom Conservancy is trying to establish that if a customer buys a product with open source components in there, and the product is not license compliant, then it's a legally defective product. It's a defective product. Just as a customer, I just bought a product, I bought the Visio, I actually owned a Visio TV set, and it's a defective product, and I can ask for the source code, and then if they don't, well, I can sue them for, they sold me something that's not a proper product. It's a potential, it's not settled, but I hope you can see the relevance, the increase in relevance of license compliance, that if it's not just one open source programmer who needs to get into the saddle to sue, but just any potential customer, including those who are just out there for money, could sue any vendor for license incompliance, then we have a problem. So open source governance, you should have your processes and all to make sure copyleft license code isn't in there. Your tools will support you with scanning your SBOMs and taking a look. What are our rules for our business model? What licenses are acceptable, which are not? So should get it flagged, what's not acceptable, etc. And so forth. All right. So copyleft is, I don't want to say it's easy, but you should be your architect should understand your SBOM, your architecture, and keep copyleft license code out. And that's why I said I find copyleft a little bit overhyped in the sense of vendors are so afraid of it, but is it that hard to keep it out? No. And in particular, the ecosystems are moving to more permissive licenses anyway. The real kicker is this one, as trivial as it sounds. I'll be fast, but still I want to mention that. So here you have our favorite MIT license, permissive. That's a great license. The whole JavaScript ecosystem is more or less built around that, so nothing like the challenges from the Linux kernel. The only requirements you have are here, 3. So you get all the good stuff from a vendor's perspective, software free of charge, etc. And then all I have to do is to provide this copyright notice, the one up here. Hopefully the developer put the name there and not just left it at copyright holder, which is very common. So the above copyright notice and this permit. So just copy the text and provide it to your customers. That's all this says. So how can you do that? Well, you need to find in all your code all the occurrences of all of this. So this is actually pretty tricky because it's so much. I need to speed up. So here's an example that I still would like to point out. This is an old Mercedes, it's 10 years old. You would still get a DVD with the legal notices where it was spelled out, copyright so-and-so, copyright so-and-so, license so-and-so, of all the components, mostly in the center console, the infotainment stack of that car. You may not be able to see it, but here's a jump. So it says GNU GPL version 2 to page 213, and then it jumps to 1307. And then the whole thing, that's the other thing, is 1,500 pages. So these are the legal notices. Nobody reads 1,500 pages, but every single open source program I mentioned in there has the right to be mentioned. And if I'm a mother or a father and I want to show my kids, look, my open source component is doing a job in our car, and then you look for it and you don't find yourself, I think you have a right to be annoyed and request that, please, Mercedes, be proper. The other thing here is 213 to 1300, GNU GPL, it says there. That's a bit misleading. That's not 1,100 pages of the GNU license text. The GNU license text is not a trivial document, but 5 pages and then A4 or so. What's the rest? Names. It's all the copyright statements. 25,000 contributors to the Linux kernel. That's mostly likely the Linux kernel, all of which have a right to be named. You have to go, so we have Yocto now and we have Debian, which is trying to set it all up properly. But in the past, you had to sift through all the source code, find all the copyright statements wherever they were listed, and compile them into that list to comply with the licenses and morally to give credit where credit is due. 25,000 people. Okay. Yeah. The structure, how Mercedes did it, I don't like it. If you want to see good licenses, third-party licenses done right, look at your Android device. You want a table of content, you want copyright statements under the component name. You need a workflow for that, and etc. It is a real threat. We have copyright trolls out there who will sue you, not over copyleft. That's a moral thing. That's what the Software Freedom Conservancy does. But just people who want to shake you down if their copyright statement isn't in there. I'll skip the details of this process because I want to get to a regulatory compliance. Just want to point out here that in Germany now, some lawyer is suing the car company, which didn't provide proper license. So Mercedes did. This is not Mercedes. Because he argues he cannot sell his car any longer because it's defective and you don't sell defective products on. He doesn't even have the right to sell the car because it would involve distribution of the software in the center console, for which he never received the proper rights from the car manufacturer because it was legally defective. Very interesting to see how that plays out. So you need to find all that, you need tools to go through that, etc. So on to regulatory compliance. It starts with security. That's the main concern usually. We think about the dependency graph, but that's a static structure. You declare your dependencies, you have them on your machine perhaps, or on your package manager out of factory or what have you. And that's what you use then. The software supply chain, however, is the dynamics of how that component makes it onto your premises. So software supply chain and dependency graph are conceptually different and need to be considered differently. And the software supply chain is that flow of code in various forms, source code, compiled, whatever, and the tools that manipulate it or move it along those chain. And that's where the attack surfaces are. That's where the potential attacks happen in order to inject typically a malicious code. So we've had a couple of these, and I think everyone's aware of not just vulnerabilities based on bugs, but now malicious and deliberate attempts to subvert the supply chain and inject malicious code. So you definitely need to track any CVEs closely. And I think any vendor has done that more or less always if they had their act together, because if your software is vulnerable and someone steals your customer's data, it's very embarrassing for you and you might be out of business soon. So while that was something that everyone had to do and hopefully always did, we now have our governing bodies, mostly I'll talk about the European Union now, who have turned this into regulation and laws. So now it's not just you yourself decide it's the right thing and it's the business savvy thing to be on top of your vulnerabilities. You really have to, or face penalties beyond being embarrassed in front of your customers. So we always had, or we had for a while, regulation with respect to existing services and protecting those. That's NIS2 and DORA for financial services as they are operated. But now, a lot of software developers here, I believe, and for vendors now, we have the Cyber Resilience Act, which addresses the vendors directly, whose software then gets used by some financial services company. And in general, it's always make sure you're on top of security standards and processes, secure your software supply chain, watch and monitor over what you've delivered because you're responsible for it. And no pulling your feet because the open source community is responsible. So the Cyber Resilience Act, not fully in force yet, but close. We're getting close. They gave us a 3-year window. Starting next year, you have to comply. Is a large body of regulation with lots of requirements. I will look at the open source part and how it results and what it leads to. So classifies everything into various products with tighter and tighter requirements. The end goal always is that you can, with good conscience, meaning nobody later can claim you did it improperly, can claim the CE mark, allowing you or documenting that you put your product on the market and that you did everything needed for that. So we have 2 levels of obligations that result from the Cyber Resilience Act. One is how you develop and get your product to market, so what you do before you deliver or distribute. And then the second set of requirements, what you do as your product is out there, doing its job and it's out of your hands, but you're still responsible. So first is product security, which you can summarize under your product must be secure by default. And then vulnerability management requirements, meaning what do you do if your product is out there and to help your customers to avoid breaches. So product security, it's structured into essential requirements. Again, this is a very large regulation, and I'll hardly go into every little detail, but they have structured into a set of requirements, so 13 top-level requirements. And maybe the very first one that I put in bold here is an obvious one, but if you're pushed and you really want to deliver, may want to skip on, but then you shouldn't, because regulation requires you not to, which is do not deliver a product to customers where there are known exploitable vulnerabilities of some criticality level. So nobody would do that if they have time. So you would update all your dependencies, make sure none of them has a critical CVE in there before you ship to customers. But then some folks may argue we have to deliver now. We can't get that update of our dependencies done, and it's so deep in the belly nobody will notice and can't be exploited anyway. The regulation says don't do that. So make sure, whether you use Dependabot or more elaborate tools, that you don't ship anything that's actually exploitable. That's is a severe vulnerability. That's pretty clear and hard and dried and cut. So you need to, once you have delivered a software release, a product release to your customers, it's not out of your hand. It's still your responsibility. Whether you have a service contract, a subscription or whatever with your customers or not, even according to this regulation, you are still responsible, even if the customer isn't paying any longer, to watch over vulnerabilities and have processes in place that include updating your users. So I have to admit, to me, it's not 100% clear, but I do read it like, well, there's a 10-year period where your customers may be outside of your original contract. Maybe there was a perpetual license, maybe there was a 10-year license, but okay, if they paid for a 10-year license, they obviously still have a contract. But maybe they're just out of the contract. You are still responsible for, at a minimum, informing them, possibly even updating them, even though they are not paying. It's some sort of product warranty, if you will, that goes beyond your direct contracts. So what you need to do is watch over your software, your products, see that there are new known vulnerabilities that became public. You need to update your software and you need to update your customers. Sounds simple? Maybe. If it's on-premise, all right. If you are highly configurable, everyone's different. That's a lot of tracking, who has what, who needs updating, who may not need updating. So in order to turn this a little bit now, go to an open source perspective, if you are an open source developer, do requirements accrue for you? After all, you put some software, make it available. There was a lot of discussion on, if you're a maintainer, are you making it available? Are you now responsible for CVEs? Do you need to respond within 24 hours, inform everyone like a manufacturer? And so the good answer is no. If you are not making money off it, then you are not responsible from the Cyber Resilience Act. None of these requirements, compliance requirements, accrue to you. If you're a company who uses that open source software in your product, then of course you still have to. So that's the difference between an open source developer and a manufacturer. There's a level in between, open source steward, people who make the software available in a defined way, like an open source foundation. And those have some requirements as they give credibility to the software. So the Eclipse Foundation, they actually pushed for the idea or notion of an open source steward. And so there's an intermediate level of requirements for anyone who falls into the category of steward, as opposed to none for the regular open source developer and a lot for the manufacturer. So the critical thing is always that as you put things on the market, you want that EU declaration of conformity that gives you the CE mark, and that creates a lot of documentation. So you need to show, all right, no critical CVEs known of what we put on the market. But All these processes that are required of you, secure by default, they want documentation too. You have a requirement to assess all those open source components beyond, is there a known CVE or not, towards, is this of sufficient quality to do its job in my product? But it certainly depends on how critical is your product, how easy will it be to update, etc. So for some, you can have some shoddy component in there, perhaps. For others, that's completely unacceptable. That's not just some CVE somewhere. You need to look at each and every component in that big iceberg under the waterline called your dependency graph and get an assessment done of, can you justify that you're distributing that to customers? So we had all kinds of fun interactions, let me get there, where then companies decided to address open source projects, remember the laughs at the beginning, treating them as suppliers. So sending an open source project, your checklist as a vendor, do you have this, do you have that secure activity, do you have that secure process, how do you handle vulnerability disclosures? No open source, so open source stewards are willing to receive that, but any regular open source project, more or less, not necessarily a hobby, but let's say lots of personal engagement beyond some paid job, will just shrug. In this case, some person poking fun at some vendor asking them, can you please fill out our supplier form? Because open source software projects, unless they take money and then become manufacturers, because most open source projects are not suppliers, they are, well, projects, community projects. So you should be smart about it. Going back to the vendor perspective, they are not, open source programmers are not suppliers. That doesn't mean they don't want their software to be used. That doesn't mean they might not be willing to help you, but obviously don't show up with some demanding voice or complaining voice. Work with the community. There's a lot to come on how we will handle that in the future, I think. So summarizing, you need to have ongoing security and vulnerability management in place. You need to, as a vendor, report within 24 hours if something's wrong and get your updates out there, even beyond existing contracts. It gets challenging if you need to track a wide variety of customers, all of which have different versions. So version hooray, and so forth. And that's it. Barely in time, but time for some questions. Yes, please.
Super interesting overview, and thanks for the talk. I was curious, looking now from a company perspective when we release open source projects. If I understand you correctly, if it's directly in our reused in our product as well, we are responsible. So far, so clear. If we now have like more research projects or like one-off where somebody developed something and just wants to show it the world under our banner, is that then also deemed a product and responsible or not? Or how is there a distinction there?
All right, so there's some legal entity, some organization, a university or a company, and you're making something available under an open source license. And you wonder now, under the Cyber Resilience Act, what happens to you? Are there any obligations? So it depends on how you relate to the open source code you make available. If clearly this is somehow commercial and you make money off it, then you are a manufacturer and the full set of requirements apply. Making money off it doesn't have to be the license. If it's open source, you're obviously not making money off the license because you just gave it away for free. But if you charge for support or updates, etc., even for just the binaries, then you are a manufacturer. If the last thing was confusing to you, just the binaries, why aren't they free? Well, that's a common pattern to give you an idea of how commercial open source plays here. The source code itself may be available under license, but most vendors in this space, Silicon Valley-backed, venture capitalist-backed vendors, will not even give you binaries under an open source license any longer. You can download binaries, but always under a proprietary license, part of the business strategy. You won't get build scripts, nothing. So open source with this pure commercial intent of there's something and an open source license to create goodwill, but we really want you to pay for the commercial version, really has very tight screws these days. And so that's nothing like your community open source software in there. So you need to look at what your intention is and whether it's set up in a way to make money. If you make examples available, just like here's something interesting and you accept outside contributions, I can imagine that there are no obligations for you. The thing is, it's very hard to answer this in general terms. I saw that the Cyber Resilience Act, which provides guidance, so there's a 70-page guidance on the 200 or whatever pages of the original regulation, explaining what happens if you have a commercial product of which you make a community open source edition available. Now that's a common one. So you have some product and then you give people an opportunity to try it and use it as a community edition. So in the CRA guidance, in my reading now, this community edition makes you a steward, the vendor behind it. I personally think you're a manufacturer, and that's simply when you ask the question, why is a company that develops software for paying salaries using someone's investment money, why are you making it available under an open source license? Not for the benefit of mankind, but you want to make money because you have venture capital and wants to see a return on investment. So the open sourcing has all kinds of benefit, some goodwill, some word of mouth marketing, all kinds of benefits. But it's also in my book a product feature because it's that assurance that you're not going to arbitrarily raise the price of your commercial product. That's what giving the world an open source version of your software does. You're promising, if implicitly, that you're not going to raise prices like crazy because there's a way to go to the open source version and not pay any license fees. So for me, it's in my book. I'm not sure it's in the EU's book as well, but in my book, having a community edition is just a product feature. And that makes you manufacturer of that community edition too. But the EU says for now, you're just a steward, as far as I can tell.
Thanks for the interesting talk. Circling back on your point of copyleft license and copying from Stack Overflow and checking the license there, with the emergence of LLMs and the way they write code, on our perspective, if we use LLMs, of course, we are responsible for the code that we're publishing, but the open source dependencies that we're using, they of course are using LLMs, and you're not aware of which license the code written by the LLM is coming from. So how is this point getting challenged in your opinion, or how should someone tackle that point? Are the tools smart enough to detect that even this is a manipulation of it's not directly copy and pasted, but can it detect the copyrights there? Thanks.
Thank you. I think I heard multiple questions. Let me try to address them. You tell me whether I got you right. So I first thought you're going to what happens if I have an LLM take an existing code base of under a copyleft license and have it rewrite in a different language and then put a permissive license on it to get around the copyleft. I'm not sure that's clear yet. I believe it will be challenged in the courts, whether that's really a new copyright that is created by the LLM, or whether that's in some way a copy and you cannot get rid of the original copyleft license. So I'm not sure I don't know about any result there, and I think it will be challenged. Then I think that was the main one. Was that your question? Yeah. Oh, okay, good.
Yeah, at Apache, we're currently struggling a bit with that problem because, well, a lot of communities are starting to use LLMs. And so I was really surprised that our legal team actually seems to see that, the legal requirements are actually leaning in a way that if an LLM sort of like produces some code, it is actually sort of like going down the alley of clean room engineering, which theoretically frees it of all these copyleft obligations. I'm not quite sure if it's really going to go down that way, but I was really surprised that a lot of legal folks who are like also doing that day and night actually are leaning that way.
Yep. Thank you for the comment. As I said, I can't answer it. I hear what you're saying, that there is a fairly strong belief in that it is like clean room engineering. I do want to point out the other set of lawsuits. It's actually two steps. How do the LLM, the code AIs, get trained? Well, they use open source code. So there are still unresolved lawsuits as to, can you just take any open source code? And does the license of that training data for your LLMs, does that not affect the code you generate? So we have examples from Copilot where the output of Copilot is an exact copy of copyleft license code from some open source project elsewhere. So Copilot or Microsoft says, of course, that is generated code. It just happens to be identical to the source. It's really hard to say that. So it's unclear on the relationship of the output in general of an LLM, or there's at least pending lawsuits. And then the second step where you said, if an LLM is actually free to do that, maybe most likely it will be clean room engineering. I do not know.
We will figure that out in the future. Thank you very much, Dirk.